If we're asked to find an unknown length in a triangle and we're given a pair of triangles, there's a good chance we can use similar triangles to actually find the unknown value. In this case, the first thing we need to consider by looking at this value y is, are the two triangles similar? Can we actually use a pattern to connect the smaller triangle to the larger triangle? So let's consider all the options to prove similarity between triangles. As you can see here, we've got angle, angle, side, 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 right hypotenuse side, and side angle side. So looking at the values that we've got in this triangle, it's highly unlikely we're going to use side, side, side because we've only got two pairs of sides mentioned. There doesn't appear to be any right angles, so RHS doesn't appear to be an option either. So our choices are either SAS or angle, angle. Let's firstly consider the possibility of angle, angle. So what we need to do is look at the angles within the triangle. We can see that we've got pairs of angles, but they don't match. So the 77 degrees definitely matches from the left-hand triangle to the right-hand one, but the 60 and 43 don't. Let's see if we can find the missing angle in the large triangle, and we do that by subtracting 60 and 77 from 180. And if we do that, we get 43. So straight away we know, because 43 degrees is on the smaller triangle, that we have two pairs of matching angles. So the similarity condition, angle, angle, is true. Now if that's true, that means that the triangles are definitely similar, and the increase in the length of sides from smaller to larger is consistent. So now let's determine the ratio of the large triangle to the small triangle, and we do that by finding a side on the large triangle and its matching side on the small triangle. So in the first case, we can see that in the bottom left hand side of both triangles we've got a 6 and a 4, a 6 on the large triangle and a 4 on the small triangle. What we'll do is we'll divide 6 by 4, and that ratio must be consistent with all matching pairs. So for example, on the large triangle there's a y, and the matching side on the right hand side is a 5 meters on the small triangle. So the ratio of y over 5 must equal 6 over 4 because the triangles are similar. We now can solve that as two matching fractions. We can see here that if we cross multiply the 6 and the 5, we can also do the same thing with the 4 and the y. So we get an equation which is 6 multiplied by 5 equals 4 multiplied by y, or algebraically simplifying the 4 multiplied by y, it's 4y, and the 6 multiplied by 5 is 30. We now solve that as we normally would do with an equation by dividing both sides by 4, and we get a y value equal to 7.5, in this case meters. So y equals 7.5 meters, and you can see again, if we have a look at the matching pairs of sides, 4 has been increased by a factor of 1.5 to get 6, and 5 has been increased by a factor of 1.5 to get y, in this case a result of 7.5 meters.